Good morning, everyone, and welcome to this NLA webinar on designing cities for increasing temperatures. My name is Benjamin O'Connor, Director at New London Architecture, and I'm delighted to be chairing this event today on the second day of COP26. As we are all aware, our planet is under severe threat from climate change. With COP26 taking place this week, we are all looking for answers to the most pressing crises we face today. Our big cities have some of the greatest challenges going forward, often positioned by large waterways with dense populations, causing drastic impacts on temperature and flooding. Research has suggested that weather conditions, especially overheating, can disproportionately affect some of the most vulnerable in our society. In order to mitigate some of the challenges that overheating brings to our urban spaces and its inhabitants, we need to be future-proofing our cities to optimise their resilience. Research has predicted that by 2050, our summer temperatures are going to resemble that of Barcelona, and therefore our cities need to respond now for this change. The NLA Resilient London report has shown how collectively the industry is coming together to tackle the growing issues of overheating in buildings and how climate change is at the forefront of every scheme's agenda. And you can download that report from the NLA website, nla.london. Today, I'm delighted to be joined by three experts on this issue who can give us some key insight into the issues and potential solutions over the next hour. This event forms part of our wellbeing programme, and I just want to thank Airflow, who are our programme champions. I'd also like to remind the audience that there will be a chance to ask our speakers some questions, and you can ask those questions throughout using the Zoom Q&A button, and I'll try and get to as many of those at the end of the event. But now over to our first speaker, and that is Marie-Louise Schembri, who is an engineer at Hilson Moran. Marie-Louise, over to you.
Thank you, Ben. Overheating. Take control there. Thank you. So overheating is not generally seen as a big issue compared to other climate changes such as flooding and flood risk, which is a lot easier to visualize generally, and there are reasons for that. And overheating and arguably even worse is water shortages are not quite given the attention that they deserve. These are some stats for London specifically, not even for England. It does change and vary as you look wider across England and across the whole world, of course, where things can be a lot more serious in other parts, especially in relation to overheating and the fires and the extremities that we've started to see. But in London alone, the increase might not seem so significant, the 2.7 degrees Celsius increase in summer, but it is, and I'll explain why. And in addition to that, there's an urban heat island effect, which adds another 10 degrees to that. And the consequences can be quite severe, especially to certain parts of our society. And there are a few stats there about flooding, which are probably worth just highlighting a few things. Of 1.5 million people in London are at risk of damage due to flood and other risks, personal risk, of course. That's about 500,000 properties as well. Perhaps little known is that we already have a deficit of water, and it will be 10% deficit in summertime of potable water. So demand is outstripping supply by about 10% or close to 10% already, and that will increase. And that's a big issue, and that will require quite a big change to our water infrastructure. And another interesting point is the aging population. Of course, not a result of climate change, but a very important topic in relation to climate change, because we are an aging population expecting a 38% increase in the next 10 years. But it's particularly relevant to overheating. And that's because I'm sorry, I need to go back there. That's because specifically people of an older group, not sure why it's doing that. There. Why is aging population an issue? So the aging population is more at risk of heat stress, but there are also secondary conditions that are more prominent later on in our lives. And we're talking about ourselves. This is not our, gran and granny. This is us in the very near future and in the medium and long term. So we will be most at risk of heat stress and other conditions that are more prevalent at an older age, and medication that we are likely to be taking at an older age makes us less sensitive to change and less cognizant of the risks coming into play with our bodies, and less able to adapt, more importantly, because generally we are a very adaptable species. We're more adaptable than we think to changes in temperatures. But not only an older generation, but also vulnerable groups with different physical conditions, or individuals who are unable to leave their home, either because of physical mobility issues, or because there's a small child in the house, because of irregular sleeping patterns, because of night shifts, and a number of other, and working from home, because if you're working from home, you're working during the hottest time of the day. One of the biggest impacts of overheating is sleep deprivation, which has other impacts on the economy and on personal well-being and performance. So overheating is a bigger issue than is probably predicted in the AC. If you look up climate change London in Google Images, all you get is pictures of flooding and perhaps, and it's always the same iconic, just to demonstrate the actual extent of that. So we're not underestimating that problem, but overheating already has some implications on deaths in the UK, as I'll show you later. It may be, the first reaction to hearing that London might have Barcelona temperature is probably a little bit positive, but we don't have buildings that are built for that kind of climate at all. We are a very winter biased type of architecture, type of urban landscape, etc. We build for cold weather, and 20% of buildings in London are already overheating. This is quite shocking, potentially, and probably predominantly new buildings as well, and I'll explain why. 80% of buildings are already built. We hear this a lot more recently because it focuses the attention on climate change mitigation on existing stock predominantly. So we're not, obviously, new build and refurbishment is only going to change a certain proportion of buildings, a very small percentage of buildings every year. So yes, buildings in Barcelona are adaptable, but they've got shutters and Venetian shutters and blinds are very effective in mitigating overheating when you're inside a house, especially. But there's a cultural change that's required as well, and we need to be able to adapt ourselves and our personal environments, and even things that our economy needs to adapt, because we need to be prepared for very different working hours and very different produce and a number of different things, and very different dress code potentially to the office. The government has published an overheating or a heating plan. The actual name is I think it was Overheating Plan that was issued in summer of this year. It's got an element of COVID-related items there because people were locked in the house, but people will continue to be indoors for a long time. People still need to sleep in their beds, where at a time when, especially in cities, the temperatures tend to go up quite a bit. That's a time of the day that we can't really adapt our environment because we're trying to stay still and sleep. We can't be getting up and doing other things or getting out of the room. So it becomes quite problematic on a large scale in the evenings. There are already about 2,000 heat-related deaths in the UK every year. This is probably going to increase. Interestingly, homes of 75-year-olds and more tend to overheat more. And this problem is increasing. New homes are getting hotter. This is primarily because, especially because in the fight to mitigate climate change, we are insulating and sealing our new buildings much better than we used to before. That's one of the issues. The other one is an increased conscientiousness of human well-being and the importance of daylight, which is making windows bigger. And better knowledge of how external noise can have long-term detrimental effects on our hearing. This is something that wasn't quite, we didn't quite pay attention to in design for a long time, up to until 2017, and there's a lot more guidance now and a lot more policy drive from local authorities to try and mitigate noise in noisy environments. And we are increasingly building in brownfield sites. In the case of London, we are very often close to a source of noise, whether it's traffic or, in more particular, in specific instances, next to a train line. Insulation itself is protecting us from heat. It's not only there for the winter time. The issue is our windows sometimes are too large, and we don't put measures in place to enable us to control solar gain, which is one of the biggest sources of heat in our dwellings. And this is an issue, of course. So it's really important to get that balance right on the design of our elevations of our facades. And the other thing is that we're introducing additional sources of heat to our buildings, in particular apartments. Apartments tend to suffer more from overheating because they tend to be single-sided and compact. And from our R&D research and innovation group, we've done quite a lot of simulation on apartment blocks and low-density residential developments as well. But in particular on blocks of apartments, corners don't really count as dual aspects unless the windows are quite far apart. So you don't get that cross ventilation that is pushed to in some instances with some local authorities in London. There's a push to creating corner apartments, but then if the openings are on the corner, it doesn't quite really work because you need that pressure differential between the different sides of a building to make cross ventilation work more effectively. And of course, it's very difficult to get proper cross ventilation in apartments anyway, because of just the nature of the massing and the sizes and locations of our sites. This image shows instances where domestic hot water pipes are running either above bedrooms or are running too far into our entrance corridors. We really need to be more conscientious about how where we place domestic hot water and just general incoming hot water pipework that's running 24/7. So this is running in summer 24/7 because that's the nature of the way centralized heating works. And also for domestic hot water, it's to keep that instantaneous hot water coming to our taps when we want it. We really need to be careful about where those are, because what you really don't want is additional sources of heat in livable space. And that's why we need to really optimize our facade. So we're not saying at all windows should be getting smaller, although it works better for solar gain and noise mitigation. We need daylight. So when looking at elevations, we really need to be optimizing window sizes and opening sizes. For this reason, we ourselves have created parametric optimization software that looks at noise, daylight, and overheating, as well as carbon reduction at the same time, because that's the way we need to design our facades going forward. We can't simply be looking at every aspect in isolation. The results of our research and the modelling and the parametric modelling tends to conclude the same results very often. The big wins are perforated shading, so not just shading. And this does add embodied carbon to a building, which is something else that we need to look out for, because it has an immediate impact on carbon emissions rather than a long-term operation impact on carbon emissions for buildings in the built environment. So perforated shading is effective. It's the most effective. It's the kind of thing you see in Barcelona and traditional architecture, and even more contemporary architecture that's more conscious of sustainability. So if you're not installing perforating shading now because of costs and facade, then at least enable it to be installed retrospectively, especially in private rental, where the building is going to be sold on. This really needs to be part of a strategy, unless you can demonstrate how to do that with an optimized window, because there are cheaper ways of doing this, but you really need to be listening to what the modelers are saying about optimum size. Air movement is an age-old effective way of improving our tolerance to heat. Stack ventilation, if only there could be a contemporary version of the sash window, or this is a pivot window in this case, but that's a lot more effective than having a single opening in glazing. There's some innovations out there, such as parallel opening windows, that are very good at achieving this. We really need more options in the market. Thermal mass is effective, but warning, not in bedrooms, because thermal mass releases heat later on in the day when you don't want that heat in bedrooms, in more typical patterns of sleep and the wake in our society. And solar control is a baseline requirement. You don't want that to be too high, because you want daylight. It does affect the amount of the transparency of windows, And it does, solar gain in winter is very helpful in our mild and cold climate in London and the southeast of the UK. Therefore, do not, there are some benchmark, usually you wouldn't exceed 0.4 in terms of soil control value. So there are limits to these improvements as well. A big solution to the urban heat island effect, and especially evening temperatures and nighttime temperatures, is greening, urban greening, especially trees. If you have some time, please look at the All London Green Grid, which is now part of the London Plan. It's a very interesting document, full of ideas on how to actually deliver a very effective urban greening strategy for London. What to avoid? This is my penultimate slide. Some really big mistakes. The one in the middle is an obvious one, but not so obvious. On every project, we do need to make this very clear. If your best views are on the south and southwest facing sides of the building, full height glazing is just going to cause so many other costs on the facade and issues later, and probably would not comply with planning anymore in London especially. You're creating a very insulated apartment, small space, and a very high source of heat during the day. It just doesn't work anymore in climate change for the future climate. So as I said before, it needs to be optimized. Restrictors are there for security and safety reasons. They're there for a good reason, but there are other solutions, window design, or openings in the facade, such as wall vents, where security and safety at height, for example, in high density development, are a requirement. So please, alternatives to restrictors are better. They are a cheap solution, but unfortunately they don't enable an occupant to ventilate their apartments adequately. Openings need to be much bigger than that. And one of the surprises, something that isn't really noticed and predicted, is how much bricks and masonry and thermal mass on the outside of buildings. We've modeled this and looked at some imagery of the temperatures that the south-facing brick facade, for example, gets to. It gets to 65 degrees Celsius at times, south-facing facades specifically, but even west-facing facades to a degree. So imagine then opening your window when you get home after an office-type schedule to cool off your apartment, and all that 65-degree air coming into your bedroom in the evening and at night. It's just not going to work, and it's something that models can't predict really. It's tempting to think of air conditioning as a solution. It is a quick fix, but it's not a long-term fix. First of all, you're throwing all that heat out into the urban space, which makes the urban heat island effect even worse. It is a high capex and high opex solution, but of course the environmental impact of not only the operational carbon effect of you're just adding more energy and more carbon in the operation of buildings, in the running of buildings, but the refrigerants themselves are the other part of the carbon of the greenhouse gas equation that's not really given enough importance. I mean, it's starting to be given importance more recently. There's a lot of greenhouse warming potential in refrigerants, and there's a lot of leakage that results from that. So you're adding to the environmental problem and the affordability problem, and it's just not necessarily something that you want to have in your apartments. There are better solutions to the traditional air conditioning that we are seeing now, for example, neutral loops, but that's a topic for another conversation if anyone is interested. And for closing thoughts, really important to look at climate change resilience at the feasibility stage of a project. Do you need to have big windows to sell your apartments? Is it something that can be avoided? Is there the cost contingency for a facade that needs to do a lot more than it used to do traditionally, because those are the kinds of things that will either make or break things later, or can be value engineered out and then make for a building that's not adapted to climate change. And really start to think of tree planting as a big part of larger schemes, not just urban greening. We need more trees. They are the solution, a more effective solution to a number of things. And that includes shading and, to a degree, air quality mitigation, although that the type of trees and the location and positioning of trees is a factor in those decisions as well. As I said before, design out constraints to large windows. Design for retrospective mitigations, such as external shutters and ceiling fans, especially in private rental, and optimize facade for environment and health as soon as possible. Do look at optimization first and not the aesthetics first. There is a balance there. There's a sweet spot, and there's more than one option for every facade. It's not just one solution that fits all, but it's really, really critical in a changing climate. And that's it for me.
Great, thank you very much, Marie-Louise, for a very fascinating presentation there. If you have any questions for Marie-Louise, do post them in the Zoom Q&A and we'll get to them in the panel discussion after. I'm now going to hand over to Ruth Shilston, who's an associate at RWDI. Ruth, over to you.
Thank you for the introduction there, Benjamin. So I'm going to talk today about the City of London Thermal Comfort Guidelines. I think this is a nice, pleasing contrast to what Marie-Louise talked about, because I'm going to talk about the spaces in between buildings rather than the buildings themselves. So as you all will be aware, London is a world-class city. It's got phenomenal architecture and an absolute growing cluster of tall towers. It attracts global corporations, world-class restaurants, and pre-pandemic millions of tourists every year. And one of the real key draws of the city is not only the phenomenal buildings that we have, but the spaces in between them. And so for the City of London, ensuring that we have really high quality amenity spaces in the form of parks, squares, spaces that we can have outdoor events is of major importance. So for this reason, when a new building comes forward and goes through the planning process, there are a number of assessments that need to be undertaken, and two of those directly relate to the quality of that internal environment, external environment. So the first one is looking at the amount of daylight that we get in an external space, and that's set out with the BRE guidelines, which some of you will be familiar with. And the second climate component that we really consider is wind. So how much wind is there moving through that external space, and how much wind is brought down to ground level by the building. And this is set out with the City of London wind microclimate guidelines, which themselves were quite groundbreaking in having specific guidelines for the UK as part of the planning process. And when we consider wind, we're looking at both wind safety. So is the wind so strong it will blow a person over? But more relevant to today's discussion is, if I want to have an external seating space for my restaurant, is it going to be too windy, or is it going to be quite comfortable? So we have these two assessments which need to be undertaken, as I say, as part of the planning process, and are really given a great deal of consideration and weight, but they're undertaken completely separately. And it's very, very difficult to combine these two assessments to understand, actually, is somewhere a really good quality public space from a climatic point of view. So for this reason, the City of London took everything one step further to develop a proper set of thermal comfort guidelines. And this is a diagram that we use to really talk about how comfortable we as humans feel in an external space. And there are a number of sort of physiological and environmental factors, which I as an engineer really like, because I can do modelling and I can measure them. So I can assess, as I've mentioned already, wind, how strong will the winds be throughout the year, how much sun is landing on the ground. I can make an assessment of how I expect a person to be dressed, their metabolic rate, which is, how fast are they walking or standing still. And also how other factors, such as how noisy an environment is, or how good quality the air is. Am I next to a road? So these are all factors that, as an engineer, I really like, because I can measure and I can model. But there are another number of other factors, which I have on the right hand side, which are the more psychological factors. So in the UK, we actually have quite an expectation that our climate is variable. It's one of the real features of the UK climate, and that's part of our culture, and it's part of our adaptation. And we do expect that we can take an umbrella out when it's wet. And also, when we're in an external environment, we accept that we don't have a lot of control over that environment. But speaking to the topic of climate change, we don't really expect in the UK to overheat when we go into external spaces. Currently, on the hottest days of the year in summer, you'll see everybody flooding out, particularly the younger generation will spend a lot of time in external spaces. which can be quite challenging for the older generations and people who have other physical impairments, where overheating actually can present a real risk to them. So there are a huge number of factors that go into how comfortable we find a public space, and how high quality that is for the people who are using it. For the purposes of the guidelines, because they were so new in the form of the UK planning process, we actually picked 4 key metrics. Those are wind speed and wind direction, humidity, so how much moisture is in the air temperature, which you'll all be quite familiar with from weather forecasts, and then mean radiant temperature and solar, which is the amount of radiation landing on a person. And we combine these 4 variables together to give us an assessment of the quality of those public spaces from a climatic point of view. And I have it in a more sort of diagrammatic here. So what we're really interested in is how windy a space is, and how much overshadowing we get. And what that tells us is that combination of the BRE guidelines and the wind guidelines that I had at the start, they tell us separately, is a space heavily shaded or is it windy? Here we're combining them together to say, okay, so we have a space and we might have done a lot of work to ensure that it's got low wind, but if it never sees the sun, perhaps it's a north-facing courtyard, then actually that space isn't going to be particularly pleasant. Or on the flip side, if we have maybe a roof terrace that might, on the initial assessment, appear to be windier than we would like it to be. It doesn't pass the wind test in terms of a seated area, but it's in full sunlight. That space gets sunlight year round. It's not overshadowed. It's south-facing. Then actually that is a really high-quality space because of the strength of the sunlight that's hitting us. Actually, even in the hottest days of the year, we'd be really appreciative of that breeze, and actually having the increased breeze would be improving the quality of that space. And that's what these guidelines do. They really combine the variables together. So what a consultant needs to do on a project is they need to run a number of computational simulations. We have climate history, and this is of huge importance. So for us to understand the quality of a space, we need to understand what the climate is likely to be in London. Now, for the purposes of the guidelines, we're looking at historic climate data. We're taking data from the Copernicus Atmospheric Monitoring Service, which is a satellite data set. And that allows us to take climate data from central London. So it's accounting for the London heat island, and it's accounting for all the buildup of heat from the buildings, which was mentioned with Marie-Louise. And that's provided as a time history. So we have 5 years of climate data running from 2015 up to 2019. We have wind simulations. As I've mentioned, wind is a key part of the planning process already, and the wind simulations that feed into this assessment of thermal comfort actually are the same ones from the wind guidelines. We have a new solar simulation. The BRE assessment that I mentioned is quite simple, and these solar simulations are taken hour by hour. So for every hour throughout the year, is that particular location expected to be in sun, or will there be some cloud cover? So it's sort of taking a little bit more sophistication on the solar simulations, which are combined together to give a metric, which is called the Universal Thermal Climate Index, which is one of a number of ways that we can put a measure against this combination of variables. And it's one that was developed specifically for Western Europe through a cost action, which is a sort of Europe government funded research project that was undertaken a few years ago. So this is the assessment that's now undertaken. As I say, it's usually undertaken using computational modelling. And what we want to take from that is not only how hot or cold a space is or how comfortable it is, but we want to be able to relate that back to how those spaces will be used. We work with the City of London very, very carefully on this to really define a number of use cases, so a number of ways that people might use spaces and the expectation of how comfortable you should be throughout the year. So all season, which is the green, is spaces that we want to be able to use, as it says, all throughout the year. So we expect it to be comfortable for 90% of the time, appropriate for use year round. So parks, key public spaces, key public squares. The seasonal is more looking at spaces, as it says, we would use seasonally. So that might be dining. Our expectations to be able to dine out in January, February are far less than they are in the middle of summer, where we really have that expectation. And then it works its way down. So we have less frequent uses, short term, for example, which are places you might stand, bus stops, and then short term seasonal, which is what we're targeting for the main routes throughout the city. So when we're walking around, our expectation, that psychological part comes back in, and if we're only going to walk from the tube station to our office, we want to be comfortable, but we don't need to be comfortable in the same way we do if we want to sit out for 2-3 hours in a park. And then transient really is not particularly comfortable. It's not really a target. It's more you have to have a bottle end. And the other comment on this, and it was something Benjamin and I were discussing before the talk started, is we've chosen a colour scale that's hopefully, or according to the tests, is suitable for people who are colourblind. So it's hopeful that this will be a very accessible standard for everybody, because it's intended that when the general public look at planning applications, they're able to view this assessment and really comment on the impact that it's having on public spaces and new private spaces. Now, I don't want to dwell on these maps because they're quite detailed, but what we undertook as part of the development of the guidelines is we did an assessment of the entire borough that is the City of London. So you can see that's the outline of the colours there, and you can see how the assessment has been applied to all the spaces throughout the City of London and all the key public spaces. I always think Finsbury Avenue Square or Finsbury Circus are quite good examples. They hit that all season and seasonal. Where they don't quite hit the all season, it's either because you're getting a fair amount of breeze coming through, or actually where a space is too hot. So within Finsbury Circus, there we've actually quite got low breeze, but you're in a lot of sun. And coming back to the theme of the session on overheating, although currently the majority of spaces in London suffer more in the winter seasons where we get colder winds or lack of sunlight and colder temperatures, as we move to a future climate, we'll actually start to see that spaces will fall off the all-season result because of the overheating risk and because we actually want more of a breeze. And where wind has historically been almost the demon in terms of thermal comfort, we'll actually start to see a desire to promote breezes in public spaces to create that breeze that we would want if we were designing for a hotter climate. And I have some examples of that. So the coloured map I showed above was as an aggregate over the year. What we can do is drill down into the data and look at a particular point in time. So this is data for June 2020. So for last summer, and it's just looking at the thermal comfort result. UTCI gives an output in terms of an equivalent temperature that you might be feeling. And actually, this was a particularly hot day in June from last summer. You can see actually a lot of the city is very, very hot. Actually, it's the spaces where we're getting more breezes around the towers that actually perform better. And we took this data and we actually morphed it using one of the climate change scenarios from the UK CIP 18 set. And you can see if you go to June 2050, and more starkly if we go to June 2080, actually how much hotter it is getting. So what we start to see is actually for these public squares, there will be an overheating risk. We will actually desire to introduce shade or introduce breezes to create that high quality public space in the future, even though it's something that's not required now. So this climate change assessment is not part of the guidelines, but I thought it would be helpful as part of today's discussion to really illustrate how, although we have a set of guidelines that's appropriate for 2021 and the design of the buildings and spaces we have now, these are guidelines that will need to evolve with our changing climate as our climate changes. And just to finish up, I thought I'd just share some of the fantastic buildings that this set of guidelines have already been applied to. So we have Finsbury Avenue Square, 2 to 3 Finsbury Avenue, which flanks Finsbury Avenue Square. So there's a real focus on the quality of the public realm in Finsbury Avenue Square and just ensuring that when we built this new spectacular tower, that it didn't have an adverse effect on that existing public realm. And then we have 55 Grace Church and 70 Grace Church, which both introduce new public spaces as part of their development. And again, there was a real focus on ensuring that for those new public spaces, that the climatic environment would be as high quality as possible. Thank you very much.
Thank you very much, Ruth. Really, really fascinating. A good way to kick up our panel discussion. Before I move on, though, I did just want to mention that Ruth and I, RWDI and NLA and City of London are working on an exhibition which is going to be opening very soon at the city centre, which is where I am now. So do keep an eye out for that, and we'll be looking at more detail into the thermal comfort modelling work they've been doing. So we're going to move into our panel discussion, but joining our panel is Jeff Southern, who's an Associate Director at IBI. Jeff, what are the key areas we need to be focusing on to ensure our buildings are future-proof for changing weather conditions?
Yeah, that's a really interesting question, and it widens the discussion even further from, I guess, where we've been. I pick up on Marie's point about the all London green grid, which is, there's a lot of data out there about what London is and how big it is, how many people exist in it, what the distribution of all the land is, what the ownerships are, and the complexities of that. So you've got all of the things that everyone's picked up on already about how to make individual changes to your building in a technical sense, whether that be the way that they're powered, the way that they're serviced, the way that the elevations are treated. And that deals with that element, depending on how wedded you are to the various kind of pushes in terms of legislation. But there's a real wider agenda, and it's been around for a long time. So 10, 15 years ago, I'm kind of going back in time in a very COP26 kind of way, and saying this is something that's been around for a long time, and we've been making moves in the right direction. But the question is, have we been making them fast enough? And I guess what I put forward is probably not. We've got a huge area, 1,500 square kilometres in London, which is a big area that is controllable, and half of it is physically green. So that half is doing the job of affecting the heat island calcs for the half that isn't green. So we're kind of trading that balance. But if we make moves that will green the island itself more, then we'll see those greater benefits. So of that 1,500, half of that is green. A third of that remainder, the other half, is buildings. But there's 2/3 of the remainder that is a lot of other space. And what some of the diagrams Ruth was showing are quite interesting in that sense, which is there's a lot of road in there, which is hard and of a certain material type and is constantly specified over and over again in that way by highways in order to deliver a product that's kind of stable. And so if I was going to say where the opportunities are vastly in that area. In the period of time, we've done really well on greening roofs. And as Ruth's shown, there are bits of buildings where roofs are green or biodiverse. And that's changed us from 20 hectares to maybe 150 hectares. But that's only the equivalent of every garden owner lifting one paving slab from their garden, maybe even less than that. And people talk about collective action. That's the kind of collective action that we could do in order to empower individuals. And then we'll find the balance, the 50-50 between the public themselves and the private sector and how they implement these changes. But to kind of come back to your question, we should just all green our buildings a lot more.
Great, thanks, Jeff. So yeah, if we can pull the slide down and get all of our panelists up on screen. So what I wanted to, we've kind of, well, first of all, audience, please do ask questions, but I've got a few that I would like to pose to our speakers first. So we're 1 second day of COP26, we kind of mentioned it a couple of times. I wonder if each of you could say a little bit about what you're hoping to see as an outcome or what you're hoping to hear, specifically around the heat mitigation, but also overall if there's anything you would be keen to hear over the next week or two as COP is on. So I'm going to come to Marie-Louise first.
Hi, thank you, Ben. I would really like to see a shift of national spending from fossil fuel to technologies that remove carbon quickly. It's a short-term solution, but it's one that is incredibly urgent. I don't think there's a real sense of how urgent this is and how much it will affect parts of the world, and it is already affecting, and how quickly it's happening. We started to see that really this summer, but it doesn't feel like every country. I mean, there are various economies, and in certain parts of the world, we all know growth means more emissions. But so there's a lot more responsibility that we hold in the UK and Europe and the US, etc., Australia, to make things better quicker. But there really needs to be an urgent shift into spend. And there's a lot of things we can individually do. And we live in this bubble of the built environment, which we can really affect and really change. New buildings need to set an example for net positive impact, rather than net zero at this stage. Net zero doesn't feel like it's enough anymore. And how can we make positive change? And it doesn't have to be financial or quantifiable carbon, but it also means being bolder with innovation, sharing knowledge across industry, influencing supply chains upstream and downstream. There's a lot more that we need to do now. And the COP26, they're the people who can influence the economic models that are financing fossil fuels. That's where I'd like to see change.
Thanks, Marie-Louise. Ruth.
So there are sort of two things on my side. I think one sort of big picture is, instead of just having targets, I want to see how are we going to achieve those targets, because I think it's, in no way do I underestimate the challenge of being a politician, but we often see from these summits that we come out with, well, we will reduce our carbon by this much by this date, but is that achievable? Is there a plan to achieve that? What is the spend, as Marie-Louise said? On a more practical and I guess built environment specific, quite different to my talk, but I would like to see more focus on retrofit. I think actually on new buildings, we do a pretty good job. There's a huge focus on developing new buildings that are lower embodied carbon, that are sustainable, that are looking at really clever ways of design. But new buildings are a fraction of our building stock in the UK, and both in terms of energy use moving forward, but also in terms of adaptation. Our climate is changing, and I would like to see a much greater focus on how we're going to adapt our existing building stock, how are we going to audit it, how are we going to understand its limitations, how are we going to prevent people who live in existing buildings from overheating, what is the plan for the millions of buildings that already exist.
Great, thanks, Ruth. I want to come back to the retrofit question in a bit, but I'm going to come to Jeff just in a second. We did have a question come through just on your slide, Jeff. We are going to share the presentations afterwards, everyone. So if you do have some facts you want to pick off there and obviously credit the speakers, then we'll be sharing those. You'll get an email notifying of that. But Jeff, COP26, what do you want to see?
Governments are notoriously bad at giving us a really clear route to an outcome. But what they are generally better at is agreeing ways to finance that route. So what I'd like is them to create a structure to break down the barrier for the retrofit piece, the individual owners who currently can't afford to make meaningful change. So I'd like to see them package it up so that you can pay for it from your stamp duty, but when you sell your property in however many years' time, so that you don't have a capital outlay, and so that the poorest people can access changes in just the same method as the richest people, a democratic approach. And then they may well not see that tax later on in 10 or 20 years' time, but that's just the cost of what we're going to do. That's what I'd like to see.
Thanks, Jeff. So sticking on the retrofit piece, it's obviously London's building stock pretty old. You pulled up a slide, I think, early on, Marie-Louise, around, I think it was 80% of 2050 buildings have already been built. And some of the sort of mitigation you had in your presentation was things we can do when we're building buildings now. Could you say a little bit more on maybe some things we could do retrofitting some of the Victorian or Georgian housing stock, which makes up so much of London? Are there sort of relatively easy things we can do to retrofit to mitigate overheating?
Yes, and there's, similar to the argument of how to help the existing stock become more energy efficient, part of that spend needs to focus on how to make sure that they continue to be properties that are livable, that people can live in, and nothing's happening that changes their personal health and well-being. And small interventions in, you mentioned historic stock, those are actually quite good in that they can be cross-ventilated. So there's a really strong element on cultural change in knowing how to deal with heat. The policy paper that the government issued last summer starts to identify how the health service, the government, can help people manage heat when it becomes extreme, which is great, but it's policy. There is some regulation coming in with a new Part L for overheating risk mitigation, but that will only affect the new stock. So there's a lot more that the government needs to do in the package that they've that we will hopefully be hearing more about after the heat policy paper was published last week, or the week before that actually. In what else, in part of that retrofit package, what other things can be done to support? The problem ones are the apartments, and buildings or units largely occupied by an older generation. Those are the ones that need to be retrofitted quite quickly, and it's a lot to do with insulation does help, but there's a lot that we need to do with glass. So windows, if we're changing windows for energy efficiency, they can't be, or what happens right now, you don't even know what kind of solar control you're getting with the window you're buying. Nobody asks that question. So improving knowledge about what a U value and a G value means in the general public, and being able to install some form of or provide financial support for installing some form of shading, plus knowledge on how to use that shading to your advantage for better sleep, for example, would be where retrofit can be improved for the future.
Thanks, Marie-Louise. Jeff or Ruth, did you have anything you wanted to add on the retrofit question? No? Okay, we'll move on. I've got a couple of questions coming in from the audience. First one is, do the design considerations mentioned adapt for a climate that is getting colder as well as warmer, as London's weather could get more extreme in winters as well as summer due to disruption to the Atlantic stream? Maybe I'll come to you, Ruth, first on the guidelines that you had. We were speaking a lot about overheating, but what about getting colder?
Certainly. So the climate change forecasts for the UK are run under the UK CP programme or SIP programme, with UK projections, and they do speak to much warmer summers. So that's why there's a real focus on overheating from all of the speakers today, and that's why this is today's topic. And within the state of the art of climate science, there's a huge amount of evidence that says our summers will get hotter. There is also a fair amount of evidence that says we expect that our winters will get stormier and more disruptive. So we might not have the average temperature get colder, but you might get longer, colder snaps or stronger winds or much, much wetter winters. Those are much harder, as I understand it, from the climate science point of view, to quantify. It's quite difficult to quantify what that looks like. So in terms of the work that we've done today, actually, it really did focus on that overheating. The other reason is that as humans, actually, and again, sort of culturally, we're quite good at adapting to being colder. It's actually much easier. We can put more clothes on. Our building stock's quite well designed. We're quite good at heating our buildings. So although it is a consideration, I don't personally think it's the biggest challenge we have to overcome. I think it's the increase in heat for our climate for the UK.
I see that, yeah, my partner used to say, there's only so many clothes you can take off, but we can
Yes, culturally it's not acceptable to walk down the road with no clothes on.
Absolutely. Jeff or Marie, on the getting colder question, or both sides, is there anything you want to add to that? Marie?
Very quickly, we are already dealing with that in trying to, because the elephant in the room is the heat demand from the existing stock, which is very leaky and very poorly insulated, is one of the biggest challenges for the built environment carbon reduction. So there's a lot of focus on that already, and that includes retrofitting better insulation for older property, making better use of the thermal mass, and switching and moving away from fossil fuels, so from gas boilers to electric boilers, and eventually switching to hydrogen. Possibly. We'll get to see a little bit more about that from the government.
Thanks, Marie-Louise. Jeff, there's a question here for you. Jeff, your strategy to green roads was an interesting one. I noticed in the presentations public transport lightly touched upon. A great deal of our transport links are underground, and these are still our Victorian infrastructures. What more innovation needs to be done to our infrastructure in order to mitigate heat on transport links and free up roads for greening? I start with you, Jeff, but I'm sure the others will have something to add to this.
Yeah, I mean, the real problem, if we look at it UK wide, I think there's lots we can do. London's an interesting case in itself and has its own challenges because of the density of people, because of the existing infrastructure with the narrow roads, the relative density of traffic per kind of square meter, and I think that's got its own challenges. But we still, and TfL and the various organisations have been doing a lot of work on making sure they don't discharge heat in the way that they've historically done from those systems. So there's a lot of systems work where we can see benefits from that in a purely engineering sense. But I think we need to see a lot more positive change in terms of transport away from private vehicles to other forms of transport. You know, it's still ridiculous that we drive a 1.5 ton car to move a few kilograms of a person, and we really need to address that purely in energy terms. It takes an amount of energy to move that vehicle, and that's what we need to address. And as soon as we can address that, then the knock-on effect is we free up more space.
Great, thanks, Jeff. Ruth, I wanted to come to you just on the transport question. When I look at your heat maps, particularly 2050 and 2080, in my mind, I'm thinking, God, imagine the tube and how hot the tube already gets. Is that something that you've been thinking about in your modelling at all? I don't know if the city have thought about that.
No, I think the tube network sits very firmly with Transport for London, but I know overheating the tube is a whole other challenge that is taken incredibly seriously, and it feeds into this conversation. So yes, how we move around, because obviously using public transport such as the tube is much more sustainable than driving a car. One of the, I think, real wins that London's had on a policy side is having our low emission zones and our areas that sort of keep cars out. More speaking to the greening of roads, there's a lot of discussions going on. During the COVID crisis, a number of the roads through the city were pedestrianised because there was that reduction in vehicle traffic and just a desire to spread pedestrians out. So we saw quite a number of roads pedestrianised. And there are discussions going on about whether there can be an increased focus on the pedestrian, which I think is obviously hugely positive as we reduce our car use. Obviously, we need to maintain bus routes through, but where you increase accessibility for pedestrians and cyclists, you can then put more planting in. So although it may not be green in terms of grass, imagine having a row of trees running up the centre of a lot of our major roads, as narrow as they are now. If we were to pedestrianise them or make them pedestrian cycle hybrid, you can then have the trees and the planting, which improves the urban heat island, which would be a real success. So I think that's part of the sort of long-term strategy, and it's sort of almost been tested during the COVID crisis, which was, sort of an opportunity taken there.
Thanks, Ruth. Marie-Louise, anything from you on that?
I'll just touch up a bit on technology for cooling. There's some fantastic innovations out there that probably don't have the right funding or the right commercial model to be, and they might come into play in the future. But for example, we've come across a solid state cooling product that's used in external environments in Singapore. That's a very, very efficient small unit that can cool environments very effectively. So perhaps in the emergency, first of all, we could deal with the cooling spaces like the tube more efficiently, quickly. If we can implement some of these technologies along the tracks or in stations, etc., or on the trains themselves. And secondly, more opportunities to capture that heat to heat homes would be great, or to heat infrastructure that you would want to be heated in summer. If there is anything there needs to be some form of. Have been conversations in the past of having a much more detailed heat map of opportunity, because the current heat maps that exist are a bit generic and not time sensitive. So I'm sure that's something that could evolve in the future to understand where energy can be shared and captured.
Great, thank you. I think it was in one of your slides, Marie-Louise, where we were looking at the temperature rises in terms of what different cities would be like. And I obviously, in my intro, said about London being as hot as Barcelona. Are there any, you mentioned Singapore, you must have been reading my mind for my next question, but are there any other innovations or interventions or pieces of research that are going on in other cities around the world that you guys think are worth us looking at? So maybe if I stay with you, Marie-Louise, and I'll come to Jeff and to Ruth.
Well, yes, I mean, maybe this sounds a little bit obvious, but traditional architecture that's been developed and it has evolved in hotter climates, we see a lot of things that we can learn from that, because passive will always win. I had that slide about air conditioning. That's what tends to happen. That's the bad example of what happens in places where there isn't any thought being given to, or any adoption of some traditional methods of constructing and building, using materials that are imported or systems that are imported from other parts of the world that don't really work in the local climate, and then stick an air conditioning on later on. And a lot of times it's done retrospectively because of cost. But I wouldn't say there are many studies on how to build in climates. And if you even look at universities in hotter climates, they've got treasure troves of information and theses about how to improve it. And they have to deal with much worse situations now. But if just looking back at traditional architecture, such as shading, cultural changes. I mean, I remember a few summers ago going to an Airbnb during summer, and the instructions included when to close your shutters before you leave the house, because when you come back later it is intolerable. So there are changes, cultural adaptations in our habits that we can learn from hotter parts of the world too.
Great, thanks, Marie-Louise. Jeff?
Yeah, I think that's a kind of overlap with Marie there. But I think that's really interesting, the lessons across different climatic areas. So, exactly as the diagram show, we're shifting towards a model from a different bit of the world. We need to address the bits that are on the extreme, where all of a sudden things are new, and we need to make rules and create an Airbnb rule set for how to live in those conditions, and try and address that. And then share that knowledge that we don't have. How do I know? I don't know how to deal with a snake in a particular place when I'm not brought up with that.
Yeah.
And I think that's something that we need to do collectively as a world.
Thanks, Jeff. Ruth?
So sort of coming back to the existing buildings piece, another piece of work that we did out of Toronto. Toronto, as a municipality, decided to do an audit of every single one of their municipal buildings with respect to climate change. So we work with them to put a framework in place to assess not only heat, which we're talking about today, but flood risk, snow, which is obviously a significant factor in Toronto, more so than here, or maybe more so in the future here. And I quite like it because Toronto doesn't have the same climate as London, but it is temperate like we are. And what they did is literally hundreds of buildings. They went through their building stock and they said, okay, for every single one of these buildings, what is the risk? What are the climate risks of this building? Is it overheating? Is it flooding? Is it snow? Is it that we have no resilience in our air conditioning system? So if the system goes down, there's no resilience to bring another system in. It was a hugely detailed study, but it shows what governments and policy can do if they make it a priority. And they really wanted to understand their historic building stock that they owned as a government, as a city authority. So I thought it was quite a nice example of what a government can do to really understand the resilience of their existing building stock.
Great, thanks very much. Ruth, Jeff, final comment from you.
Yeah, I think that just that idea of data, the dashboard of data that governments, local authorities, and across the world hold. So if that data can be connected together so that it's meaningfully accessible and can be worked with, then I think that will be key. Whether it's a bid in London or whether it's Toronto's municipality.
Right, just quickly, Ruth, is that Toronto study publicly available?
I'm not sure. I can find out. It would certainly, we've presented on it, but whether the data itself is publicly available, I don't know off the top of my head. My apologies, but I can find out for you, Ben.
Sure, great. And we can send that over with the information we're going to send out. So I want to say a huge thank you to all of our speakers and for all of you who are watching. We are going to share those presentations today. There are lots of interesting stats and facts there. We've got some other programming around this issue for COP26 over the next 2 weeks. I think we've got 3 or 4 events, so do check out our website, nla.london, and I hope to see you at an event very soon. We're now just going to throw a quick poll on the event, so do give us some feedback. And yes, have a great week and hope to see you all very soon. Bye-bye.